Hello everyone, welcome to Physics is Fun. Today's problem: suppose a force which is shown in this graph is acting on a body, and the force is acting on the body from 5 second to 5.5 second, and after that interval of time the force is withdrawn, and when the force is withdrawn then the body covers 6 meter in the next 3 seconds. Question is, find the mass of the body. So basically, as you can see, if you just see the values, say 1000 Newton force is acting on the body for 0.5 seconds. So this type of force is called impulsive force. So when a force of very large magnitude is applied on a body for an extremely short interval of time, then such a force is called impulsive force. And the change in linear momentum that it brings along, that is called the impulse. Okay. So if I find out the area under this graph, means if I find out the area of this rectangle, so that will give me force multiplied by the time interval. Okay. So what do we know? F is equals to delta P by delta T. Right? We studied this already. So the change in linear momentum of the body is basically given by F times delta T. As you can see, a constant force is acting on the body. So linear momentum is 1000 multiplied by 5.5 minus 5. So 0.5 into 1000, that will give me 500 Newton second, and that Newton second is also called kg meter per second. So this is the impulse. What is impulse? The change in linear momentum of the body, which is caused by this very large force acting on the body for an extremely short duration of time. Now the body was initially at rest. So according to the problem, initial velocity of the body is 0, and after the force has been withdrawn, the body covers 6 meter in 3 seconds. So final velocity of the body is 6 meter divided by 3 seconds. So that is nothing but 2 meter per second. Okay, so now very easily what we can say, therefore delta P is m times v minus u. So or 500 is equals to mass 2 minus 0. So of course 2 and 500 will cancel off, and the value of m will come out to be 250 kg. So your answer is 250 kg. And what is the core concept of this problem? What is the core concept for this problem? When a large force acts on a body for a small interval of time, then such a force is called impulsive force. And the change in linear momentum that it brings along, and the change in linear momentum that it brings along is called impulse. So that is the core concept. Okay, and since this force, as you can see, this is basically bringing the body into motion from its initial condition of rest. So definitely this force is an accelerating force. It is not a retarding force. It is an accelerating force. and therefore the change in linear momentum is m into v minus u. Why? Because v is greater than u. Okay, so here the acceleration is positive. So as the acceleration is positive, greater than 0, so definitely v is greater than u. So change in linear momentum is m times v minus u. Had it been a retarding force, it would have been m times u minus v, because a is less than 0. I hope you have understood this problem and it has cleared some concepts on Newton's laws of motion. Thank you everyone.